Well, while they're getting that going, let me introduce him. So Cesar Barta, physicist and University of Complutense in Madrid in 1981. Cesar Barta has developed his professional activity in the nuclear and electronic fields. At the final period, he worked as a test engineer in space science for more than 25 years. He devotes his free time to research and dissemination on the Holy Shroud, having taught courses and attended conferences both in Spain and in other countries in Europe and America. He assiduously collaborates with national and international specialized magazines. He has been involved in shroud research following its 1988 carbon dating, and he is a member of the Centro Español de Sindonología, CES. Welcome, Cesar. So good to have you.
Okay, does work. I'm Cesar Barta, and first of all, I have to thank the organization, and particularly to Joe Marino, who contacted me first and encouraged me to present, to contribute to this Congress. Well, I am physicist and a member of the Society of Catholic Scientists Spanish section, and also of the Centro Español de Sindonología. Well, now I'm retired, but I work for more than 25 years in the spatial industry, and one of my notable job was to test this spacecraft that is now on the moon. Usually, I stop here about this subject, but now I will to confess that the spacecraft is on the moon, but the owner of the spacecraft lost the control 10 seconds before landing. Then the spacecraft is on the moon, but a part here, a part there. Okay, well, and this is for remember that you can study the Sudarium of Oviedo in English, because this in my book is the current Bible of the Sudarium. Okay, then now I start with the dating of the shroud. I hope you attend the presentation of Jackson about the method of the radiocarbon dating, because he take 40 minutes to explain the technique. Then I have more time to other things. And surely you know the laboratory received 3 samples taken from this corner, and they were sent to 3 laboratories, Oxford, Arizona, and Zurich. Tristan Casabianca also explained everything of this, and the result were published in the scientific journal Nature. This is the original table of the result, and the laboratory received 4 samples of different origin. 3 of them were control samples, and one of them, the shroud, was considered the unknown sample. The result for the shroud give an age that of only about 700 years. Then more or less the 14th century. But in the same table, this is the copy of the table, the significance level, as Tristan told this morning, in the previous version was lower than 5. In this case, that means that the measurement was not reliable because the sample was non-homogeneous. In this case, there was an anomaly if we compare with the usual practice in the scientific field, because the laboratories held a conference press before to publish the result. If this result will be published before to the conference press, maybe the laboratories want to say another thing. Want to say, well, we know with this significance level, we know the age of the 3 control sample, but we not know the age of the shroud. In this case, the laboratories could be discredited. They can have a problem. But the history was the other way. Well, to explain this low confidence of the result, the possible error or mistake of the date, several explanations had been proposed. The fire and the pollution qualitatively can explain a change of the date, of the radiocarbon date. But quantitatively, when you make calculation, the shift of the date, of the true date of the sample can be several years or 1 or 2 centuries younger, but not 14 centuries. Then the fire, the pollution cannot be an explanation for the result we obtain. The explanation that finds more consensus is the patch, but I'm talking about the other explanation, the hypothesis of neutron irradiation. I have to note that among the known radiation, only the neutron radiation can justify a change of the radiocarbon dating, because the alpha, beta, and gamma radiation cannot modify the radiocarbon dating. Well, somebody say, but this hypothesis is not a scientific hypothesis. But as soon as 1989, in the same issue of the journal Nature, some page further, Thomas Phillips proposed this hypothesis, as if the shroud receives irradiation with neutron, the date was false, was not accepted. And as every scientific hypothesis must have, in this case, we have also the theoretical model. The linen is a cellulosic product, is a cellulose polymer. Then they have carbon, hydrogen, oxygen, and when a thermal neutron reaches the isotope carbon-13, this isotope transmute to carbon-14. And this is the hypothesis proposed by Thomas Philip in the journal Nature. But also the oxygen isotope 17 of oxygen can transmute to carbon-14 if it receives a thermal neutron. But in any case, the most important for this topic is the impurities of nitrogen. The natural flash had about 1% of impurities of nitrogen. And nitrogen have the highest cross-section to capture the neutron. Then, with only the 1% of impurities, the effect of the neutron is the most important. This was not taken in account, but the first hypothesis of Thomas Phillips. Then, if cellulose receives thermal neutron, they theoretically can transmute to, can increase the amount of carbon-14. But not only there are a theoretical support, there are also the experimental support. Linen samples were irradiated with this amount of neutron, 10 to 14 power neutron by a centimeter square, and were used for radiocarbon measurement. What they found? Neutron irradiation of linen increased, in fact, the radiocarbon content that was not removed by high temperature or by the chemical cleaning treatment used by laboratories in 1988. Yes. Then, if the Turin shroud receives neutron irradiation, its carbon-14 content will increase, causing its radiocarbon age to be younger. But people ask, but where do neutrons come from? The hypothesis proposed that they came from the rapid body. This is the hypothesis of Raber-Racker. But corpse does not emit neutron. It must be a singular event that cannot be reproduced in the laboratory. This is an objection to be a scientific hypothesis. Well, in the case of the Big Bang, it is also and singular event that we cannot reproduce in the laboratory. But in the case of the Big Bang, there was a model that predicts the background radiation that was detected. Then, in the same way, the singular event that irradiates the shroud with neutron can be detected by some method, but some technique. This is the purpose of my research. Well, some detail of the Racker model. In the hypothesis, the quantity, the amount of neutron is proportional on the mass body density. Then there must be more dose of neutron in the chest level than at the feet or head level. More dose here than in the head or feet. This is why the profile of neutron dose or the corresponding radiocarbon date is this way along the body or along the shroud. Another thing is the theoretical behavior of the neutron say us that the neutron that reach the limestone, the stone, can return to the shroud, can bound back this way. Then, in the dorsal part of the shroud must be more dose of neutron than in the frontal part of the shroud. This is why the profile along the longest axis is this way. The model predicts a profile along the body in dorsal and frontal part, but much those in the dorsal part than in the frontal part. Well, this is the hypothesis, the model. Now I have to test this hypothesis. And we have several clues, not evidences, but clues. I am talking about these four clues. The trend in the dated sample, Robert Racker told about this already. The ultraviolet fluorescence that Matt Cavoy explained also. Other not destructive technique and the dating of the Sudarium of Oviedo. Well, start. As you know, the three samples taken for laboratories were near each other, and they show a trend that the date was more younger as the sample was closer near the body. This is just the plot that I see in an hour before in the other room. This is the trend of the dated sample. The more near the body of the sample, higher or younger the dated. Well, what performed Racker? He tuned his model in the way that the mean of the intensity of radiation justified the 14th century in the dating shroud, and then he found a profile along the whole body. The profile at the feet level match more or less the model. This is the first clue that confirms the hypothesis. But the most important clue is the ultraviolet fluorescence. In 1978, several photographies in ultraviolet were recorded from the shroud. This is the profile of the model of neutron irradiation, but Thomas McAvoy found that the data recorded from the shroud, the ultraviolet fluorescence recorded from the shroud, follow the same profile as the neutron irradiation. I don't know if you realize the importance of this finding, because whatever could be the phenomenon that produced the ultraviolet fluorescence, the fact that it followed the profile of the body, that implied that the phenomenon came from the body. Something that produced the ultraviolet fluorescence came from the body. Then McAvoy wondered if neutron produced ultraviolet fluorescence. And then he sent several samples to a nuclear reactor to irradiate the sample. And yes, he found that the ultraviolet fluorescence correlates with the dose of radiation. It is easy to see this effect. The irradiated sample fluoresces much more than the control sample. What is the ultraviolet fluorescence? When a ultraviolet light reaches the sample, some electrons are reach with a higher energy level, and this electron lost some energy by dissipative path, and finally they fall to the ground level, emitting visible light. Well, until now, I say nothing new. So, thank you for your patience to listen at this moment, but I hope I can compensate your patience with some novelties after this. Well, McAvoy sent sample to a reactor, nuclear reactor, and the sample received three types of radiation: fast neutron, thermal neutron, and gamma ray. Then he found that the more radiation produced more ultraviolet fluorescence. We have to ask, but is the neutron or is the gamma that produced the fluorescence? Then, with the same control sample used by McAvoy, I sent several samples to be irradiated with pure gamma, with pure gamma. Then what I found, it's gamma radiation that produces the fluorescence. I found that no, the gamma radiation does not produce increase of fluorescence. Then we have to conclude that are the neutrons that produce the fluorescence. Gamma radiation does not produce fluorescence, neutrons do produce fluorescence. This is the first step forward. This is the profile along the longest axis of the shroud, but what about across the shroud? In the Rucker model, there are also a profile, and there are more more neutrons in the side, in the edge of the facing the wall, that in the other side, because the neutron can reach the stone and bounce back, return to the shroud, increasing the neutron dose. Now I can ask if, and in the case of the fluorescence, there is also a profile? Yes, there is also a profile confirmed by Thomas Mascavoy. But the more intensity is in the side of the chest bone, in the chest bone side. More fluorescence in the side of the chest bone. Then the question is, was the bone facing the wall? Now I ask you to pay maximum attention because the following slides are difficult. I try to answer the question if the body was this way or this way. And to try to answer, I analyze the blood belt on the back of the shroud. Okay? This blood belt overflow the body, the image of the body, and it is confirmed by the oldest representation of the Shroud of Turin in the batch of pilgrims in Lirey, France. Then the blood belt must be on the shroud, but not on the body. When, as the blood belt in the edge is confused with the bone, it's not easy to see where they start and where they finish. But when analyzed by ultraviolet in detail, the trail overflows the left side but meets the edge of the right side. Why? What is the explanation? Well, I propose that when the body was placed on the shroud, the bone chest was bleeding and the blood dropped on the shroud. Let me see this several times because I am very proud of this. Okay? We can see now what happened in the sepulchre. Okay, then let's see it from above, the thing from above. The shroud was placed on the stone and the body was in the side that allow the access to the stone. And the chest bone was bleeding, and when the body was placed on the shroud, the blood dropped on the shroud and left the blood belt. Then, if this reconstruction is correct, to explain the characteristics of the blood trail, the bone will have been facing the wall. Then, this new contribution is that as the neutron model predicts more dose in the side of the wall, the edge of the wall, side of the wall, the fluorescence also present a maximum at this same site. Well, another technique, I tried to find non-destructive technique, because destructive technique are difficult to obtain permission. This technique was already published. It is the Raman spectroscopy. The background fluorescence of the linen increase with the dose. It is correlated with the dose. Then, with Raman spectroscopy, we can verify if there is a profile on the shroud that corresponds to a profile of neutron irradiation. The question is, but this finding is with the sample provided by Thomas Mazcavoy that were irradiated in a nuclear reactor with three types of radiation. Then I test that the sample irradiated with pure gamma that not produce background fluorescence in the Raman spectroscopy. Then this technique allows to detect the profile in the shroud. But we have data of Raman spectroscopy from the shroud? Yes? Yes or no? We are seeing. In 2002, where the restoration, Raman spectra were recorded in the shroud with red light. At least in 9 spots on the hidden side, that it even better that for this technique is better that that data came from the hidden side. The data were delivered to Cardinal Poletto. After 23 years, nothing is known. Where are the data? Okay, this. Okay, but there are that data of ultraviolet spectroscopy, because in 1978, Gilbert and Gilbert recorded some spectra. They take spectra from several spots, and the data came from the blood, from the brain, from clean. Then only 4 spots provide the spectra from clean point. I I performed the exercise to found where the model of Racker, what is the age of the model Racker that correspond to the clean point where we have the ultraviolet spectra. Well, we found that the correlation is not clear because we have an outlier. Only with 4 points we can have no conclusion. But there are more ultraviolet spectra. Yes, in 2002, in the same case, in the same time as the Raman spectra, fluorescence spectra were recorded from the Shroud. Maybe in the same spot as in the Raman case, along the hidden side. The data were delivered to Cardinal Poletto, and after 23 years, nothing is known. When I am finishing with the dating of the Sudarium of Oviedo. As the Gospel associated with St. John said that the Sudarium was placed not with the linen but rolled up in a apart place, if the body emits neutron, as the distance increases, the dose decreases. Then, according to the model of Neutron, at the chest level, the predict date is the 85th century. Well, I remember you that we are in the 21st century. At the fifth level, the model was tuned to give the obtaining date by the laboratories. Then 1350 AD. Then, about 50-60 centimeters far from the body, the neutron dose must correspond to more or less 750 AD. That is the radiocarbon dating obtaining for the Sudarium. Then, with only one hypothesis, we explain the trend of the three dated samples, the profile of the ultraviolet fluorescence, and the dating of the Sudarium. For conclude, the ultraviolet fluorescence profile of the shroud indicates the radiation coming from the body. This is very important. Neutron radiation will produce this profile of the ultraviolet fluorescence. Neutron radiation makes the carbon-14 increase and made a dating younger. Then measurement already made, but not known, or to be carried out on the Shroud and the Sudarium of Oviedo can confirm or rule out this hypothesis of Newton irradiation on these clothes. Then, thank you very much. Matkaboy.
Who's Cardinal Poletto, and where is he? Is he?
Cardinal Poletto. What is not or is not yet the cardinal of Turin, was the cardinal of Turin in 23 years ago. Now, the data must be in the cathedral, under the responsibility of the new cardinal, but I don't know.
Oh, thanks. Could you help me explain one thing? Let's see. Do you mind stepping here for a second? I just want to
I have to
understand.
go.
So the blood belt is off center, right? It's further from here, from the wall. I mean, it's,
Okay.
so you were thinking that the body would have been like this?
Yes.
Okay, that's,
Okay.
okay. I just wanted to confirm.
Okay. It's only for confirm. Yes. The blood belt is masked by the Barnett part. Then it's not easy to confirm where the blood starts at where the blood stop. But the best study about this show that it overflow by the left and stop at the right.
Is there a proposed mechanism by which neutron flux increases UV fluorescence? Are there specific proposed chemical changes that happen, or what is the mechanism?
¿Se hay algún mecanismo que puede subir el flow de neutrons?
Well, the mechanism for justify the increase of the fluorescence. This is a fact, but to explain what happened inside the molecule, the compound, in our article we propose some mechanism. The thermal neutron have low energy to produce chains, chemical chains. But the fast neutron can move the hydrogen and the other nucleus that can change the bond of atom. But it's not verified, it's not confirmed.
Cesar, can I just ask, essentially, UV fluorescence proves neutron radiation.
Proton. What?
Fluorescence proves neutron radiation.
Well, yes, it's a logical conclusion that the neutron produce increase, the more the neutron, more the ultraviolet fluorescence. But there are other mechanisms, other phenomena that produce the ultraviolet. For example, protons. It is a research to be done.
Okay, but essentially, radiation causes the UV fluorescence because they are still arguing that some other mechanism caused the image. Whereas what I'm hearing is you're saying radiation, in this case neutron radiation, must be involved because of the results of UV fluorescence.
Yes. Yes. Well, there.
Are there any efforts to investigate the effects of neutron radiation in the walls of the tomb or in the stone that the body was laid upon?
Y si hemos
Se está haciendo algo para investigar.
Okay. Well, first thing, actually we know where is the true sepulchre. If we think that the sepulchre is the true sepulchre, the live storm is under marble es láminas, ¿cómo se llama?
Laminates, marble laminates.
Slate, no? Okay. Then, when the restoration of the sepulchre was done several years ago, I don't know if somebody take samples, but this sample can be very useful for the site if there reside or not neutron, because the calcium 41 is almost there are not, this isotope is not present almost nothing in the nature, but in the case the ¿cómo es ¿cómo es? Caliza es well, the stone has calcium, and if the calcium receives neutron, they transmute to calcium 41 that it's easy to see if there are an increase. Limestone. This is the word.
What is the half-life of calcium 41?
What is
the half-life?
Several tenths of thousand.
Thought-provoking model was just thermal neutrons, correct? Is that what I understood?
Es el modelo de Roque era thermoneutrons.
I remember that the question is if the model take account only thermal neutron and also another the energy spectrum of the Racker, I think is not only thermal neutron, but the simple hypothesis is that not only thermal neutron came from the body, they must have a spectrum of energies. Then maybe the irradiation of neutron present several energies. But we don't know.
Do they have the spectrum? Does he have the spectrum available to?
No, you have to ask Robert Racker for that.
We'll have to end there. Think you could answer any other questions in the hall, please?
Okay.
Thank you.
¿Eso también? El láser.